Okay, for asymptote, if limit as x tends to a equal to infinity, x equal to a vertical asymptote, you know that. If limit as x tends to a of f of x equal to b, you have a limit point a b, because in that case x is impossible, undefined. So as x tends to a and you have a point b, you have a limit point in it. It starts from a point a b and this point is not included, for example. If limit as x tends to infinity is equal to a, so y equal to a horizontal asymptote. Now the study. If limit as x tends to infinity equal infinity. So you go and you do limit as x tends to infinity of f of x over x. If the answer equal to 0, you have a curve parallel to the x-axis. For example, when it goes, for example, up, it will become parallel to the x-axis, either from up or from down or from that side. It's not asymptote y equal to x, but it will be parallel. So if limit as x tends to infinity equal infinity, we do limit as x tends to infinity f of x over x. If it's 0, parallel to the x-axis. If it's infinity, it will be like the exponential that we saw before. It will be parallel to the y-axis, either from up or from down or from that side or from that side, parallel to the y-axis as it goes to infinity. Halla, if it is equal to a and you have this, you have a number, you go and you do limit as x tends to plus or minus infinity f of x minus ax. Halla, if you have it infinity, you have y equal curve y equal ax parallel to this curve. What does it mean? And if you're graphing, somehow it will become parallel to this one. When it will be parallel to y equal to ax, when you have limit as x tends to infinity, if you do f of x over x, you have a number. However, when you do f of x minus ax, it is equal to infinity, it's parallel to y equal ax. If it's equal to 0, in that case, y equal ax will be asymptote. Okay? If it's b, you have a number b, for example. So you have limit as x tends to infinity, f of x over x is a. Then you do f of x minus ax, you're going to get also a number. You do f of x minus ax plus b. If it is 0, you have oblique asymptote. If it's infinity, the curve parallel to y equal ax plus b. So you need to memorize this table. We're going to see the importance of this table, for example, when we're going to start solving. Okay? The importance of that table when we start solving. Graphing. Let us see the first graph. We want to graph y equal ln x. Domain x bigger than 0. We do limit as x tends to 0. Ln 0 is minus infinity. X equal to 0 vertical. Limit as x tends to infinity. Ln infinity is infinity. So we do first of all limit as x tends to infinity f of x over x. So ln x over x, infinity over infinity, Hospital's rule, you have y equal to 0. What did we say when it is 0? We said when it is equal to 0, here curve parallel to the x-axis. So we do now the derivative. It's 1 over x. Since x is positive, so it's always increasing, so it's plus. So limit as x tends to 0, you have minus infinity, and as x tends to infinity, you have infinity. But how? Parallel to the x-axis. You can take particular points by using the table of in calculator. You have the table in calculator, you do it, you can pick as much as you want, and I have picked only 0.1. Ln 1 is 0. You can pick e. Ln e is 1. So this is ln e, which is 1. Here e. So it becomes parallel, as you can see, to the x-axis as it goes. Here x ln x, we know that x bigger than 0. Limit as x tends to 0, you have 0 times minus infinity. We need to do Hospital's rule. I keep ln x up and 1 over x down. We do Hospital's rule. You have 0. So I have 0, 0 limit point. So this point, we start from this point, but it is not included. Limit as x tends to infinity is infinity. We do limit as x tends to infinity, second step, f of x over x. So it's ln x, it's infinity. So curve parallel to the y-axis. Why? Because I have infinity and then another infinity. You can check here. If you have here infinity And if you do this one and you have infinity, it's parallel to the y axis. So here the curve is parallel to the y-axis at infinity. So we do the derivative, u times v, so 1 ln x plus x, derivative of ln x is 1 over x, so it's ln x plus 1. You equate it to 0, so ln x equal minus 1, so x equal e power minus 1. You take a number bigger than e minus 1, you can take for example 1, and you replace it in f prime. You can realize it is positive, here positive, here negative, here negative, here positive, decreasing, increasing. Here you have 0 limit point, here infinity parallel to the y axis. And if you replace here by e minus 1, you're going to get e minus 1 ln e minus 1, so minus e minus 1. So this is the minimum. Okay, coming from this point, it goes up parallel to the y axis. You can take particular point by taking the table in calculator. More curve to study. Here you have ln x over x, x bigger than 0. If you do limit as x tends to 0, you have minus infinity over 0 plus minus infinity, x equal to 0. As you can see, here is a vertical asymptote. Infinity, you do Hospital's rule, because infinity over infinity you have 0. So you have y equal to 0 horizontal. You do the derivative, u over v, you have this one, you equate it to 0. So ln x equal to 1, x equal to e here. Take a number after e, you see it's minus, before positive, going up, down. This is the maximum e minus 1. E is, so here somewhere the maximum, it goes from x equal to 0 maximum and then go to the vertical, to the horizontal asymptote. Hala, if you want to graph x ln x, what is the domain? أول شيء I have ln x down, x bigger than 0 inside ln, and ln x cannot be 0. Why? Because denominator cannot be 0. So I say ln x not equal to 0. So x not equal to 1 e power 0. So you have x belong from 0 till 1 up till 1 infinity. So I start by doing limit as x tends to 0 plus. So 0 over infinity is 0. I have limit point. This point is rejected here. And if you do limit as x tends to infinity, infinity over infinity, Hospital's rule. So you're going to get x, which is infinity. So since limit as x tends to infinity, I have infinity, I do f of x over x. So f of x over x, I get 1 over ln x, a number over infinity 0. So it's parallel to the y-axis. So here, as you can see, parallel to the y-axis. Here I have rejecting point 0. If you do limit as x tends to 1 minus, 1 is 1 over ln 1, which is 0. But 1 minus, yani ln 0.999, it's 0 minus, so minus infinity. And here plus infinity, I have a vertical asymptote. You do derivative, this is of the form u over v. You have this one, you can check it by yourself. I'm going to get e. Okay, if you take a number after e, you replace it here. It is positive. Before it is what? Minus. So going down and up. So you have x equal to 1 here. Let me do another one. X equal to 1 vertical asymptote. If you have e, for example, e here, you have here. So what do you have? You have rejected point, not included, going down to y equal to 1, and then coming from up to e, and then parallel to the x-axis. It must be like this. So coming here, minimum, then going up till parallel to what? To the x-axis. So that's why I did it. Okay, do it by yourself again. More curve. So here I want you to do it by yourself. Certainly x bigger than 0, you do a limit as x tends to 0 plus, so infinity, vertical. If you do f of x, you have infinity minus infinity, you put x in factor. This is Hospital's rule, it will be 0, so it will be infinity. You do f of x over x, it will be 1 minus ln x over x. Here if you do Hospital's rule again, here will be 0, so you're going to get 1. This is the first time we get a equal to 1. Since a is 1, now we do f of x minus ax. So f of x minus ax. So you're going to get f of x minus x. So you're going to get minus ln x. And if you do minus ln x, you're going to get minus infinity. In that case, y